Welcome to this video on alkanals and alkanones. Alkanals have a carbonyl group, which is an oxygen atom double bonded to a carbon atom as their functional group. Sources of alkanals include essential oils, sugars, air, and the oxidation of primary alkanols. The general formula for alkanals is CnH2NO, or CnH2n plus 1 CHO. For methanol, where N equals 1, the molecular formula is C1H210, or HCHO. This slide illustrates the molecular structure of methanol. The condensed formula for methanol is HCHO. Moving to ethanol, where N equals 2, the molecular formula is C2H22O, or C1H3CHO. Here is the molecular structure of ethanol. The condensed formula for ethanol is CH3CHO. For propanol, with N equals 3, the molecular formula is C3H23O, or C2H5CHO. This is the molecular structure of propanol. The condensed formula for propanol is CH3CH2CHO. Next is butanol, where N equals 4. Its molecular formula is C4H240, or C3H7CHO. This slide displays the molecular structure of butanol. The condensed formula for butanol is CH3CH2CH2CHO. Finally, for pentanol, with N equals 5, the molecular formula is C5H250, or C4H9CHO. Here is the molecular structure of pentanol. The condensed formula for pentanol is CH3CH2CH2CH2CH2CHO. The same principles apply to other alkanals, including hexanol, heptanol, octanol, nonanol, and decanol. Alkanals are prepared by oxidizing alkanols, using potassium manganite as an oxidizing agent, as shown in the reaction for ethanol. Regarding physical properties, solubility decreases with an increase in molecular size, while melting and boiling points increase with relative mass. Additionally, the density of alkanals increases with molecular size. They are colorless and possess a characteristic smell. Chemically, alkanals undergo combustion reactions, reacting with oxygen to produce carbon dioxide and water. They also undergo oxidation reactions, such as ethanol reacting with oxygen to form ethanoic acid. Alkanols react with hydrogen cyanide to form 2-hydroxylpropanonitrile. They also react with sodium hydrogen sulfite to form ethanol bisulfate. Finally, alkanals undergo reduction reactions, such as ethanol reacting with hydrogen to produce ethanol. Now let's look at alkanones. They have a carbonyl group, Rc equals OR as their functional group, with oxygen double bonded to 2 carbon atoms. Sources of alkanones include the oxidation of secondary alkanols and their creation as byproducts when body fats provide energy. The general formula for alkanones is CnH2NO, or CnH2n plus 1 CHO. For propanone, where N equals 3, the molecular formula is C3H230, or C3H60. This slide displays the molecular structure of propanone. The condensed formula for propanone is CH3COCH3. For butanone, where N equals 4, the molecular formula is C4H240, or C4H80. Here is the molecular structure of butanone. The condensed formula for butanone is CH3CH2COCH3. For pentanone, where N equals 5, the molecular formula is C5H250, or C5 hydrogen oxide. This is the molecular structure of pentanone. The condensed formula for pentanone is CH3CH2CH2COCH3. For hexanone, where N equals 6, the molecular formula is C6H260, or C6 hydrogen oxide. This slide illustrates the molecular structure of hexanone. The condensed formula for hexanone is CH3CH2CH2CH2COCH3. The same principles apply for other alkanones, including octanone, nonane, and decanone. Alkanones are formed by the oxidation of alkanols, such as propan-2-OL, being oxidized to propanone, using acidified potassium dichromate or potassium manganite as the oxidizing agent.